Good afternoon. My name is Alex Davidovich, and I would like to tell you about my presentation. The topic of the presentation is called hydraulic fracturing as a part of the well stimulation process and its importance for Canada's oil and gas. Briefly, what's going to be covered in this presentation. So I'll explain how hydraulic fracturing works, and I will explain you the reasons why hydraulic fracturing is used in the oil and gas industry. Also, I'll tell you about formation stresses, fracture orientations and pressures, and about fracture fluids and fracture proppant. It's going to be general information for understanding the fracturing process. Also, I'm going to give you reasons why hydraulic fracturing became a very important part of Canadian oil and gas industry in the recent years. Also, I'm going to mention what can potentially go wrong during frac jobs, the consequences of negative consequences of the process. At the end, there will be a summary where I briefly describe my conclusions. I'm familiar with fracturing because currently I work as a fracturing operator, so this topic is very close to me. So let's start from the general information. Hydraulic fracturing aims to create a conductive path into the formation, permitting easier flow of fluids to the wellbore, and the wells are fractured to increase the flow capacity of the producing zone. Often new wells are fractured when the new zone is too tight to produce at a commercial rate. And in this process, the fracturing fluid is injected at a rate faster than the fluid can leak off through the matrix of the rock, which results in pressure rise that breaks the formation. Continued pumping widens the fracture and extends it out from the wellbore. So the fracture fluids is usually gelled water or oil or foam, and the proppant, which is sand, is injected in this liquid. This proppant keeps the formation stresses from closing the fracture after the hydraulic pressure has been released. There is a slide with pictures in my presentation, and you will see a brief description of the frac job. Also, my slide, one of the slides shows the formation stresses, so it's an inevitable part of the fracturing process. So formation stresses are related to earth forces such as overburden and confining loads produced by faulting, uplifts, tectonic plate shifts, and other factors. These pressures are around 20 kPa a meter. The actual direction of the fracture extension, once the wellbore is left behind, is perpendicular to the plane of least principal stress. This concept requires the least energy. So in the slide you will see the picture. So there is an initial parting pressure needed to part the formation and fracture that can be propagated with further injection of fluid. This injection has to be at a high rate as there is a leak of fluids from the fracture into the formation. And at some point, the total rate of injection is faster than the fluid can leak off through the matrix of the rock, which results in a pressure rise that breaks the true formation. And there is an illustration that shows a relationship between surface injection pressure versus time during fracturing process. Excuse me. So after the fracture treatment has been pumped, the sharp drop in pressure corresponds to instantaneous shut-in pressure, which is ISIP, and the slide contains the picture. So for the frac job, the most common fracturing fluid, like I said, is gelled water. Most common polymers for gel and water will include guar and hydroxypropyl guar. Proppant type selection is based on the hardness of the rock, basically the design of the frac job, right? It also depends on the effect of the produced fluids and the stresses imposed by the closure of the fracture. So the proppant size selection is based on the strength and flow conductivity needed to produce the fluids. Also, in my presentation, there's a slide that has a picture showing the fracture conductivity of sintered bauxite versus regular sand as proppants. It is obvious from the graph that sand loses its conductivity after a certain depth when compared with sintered bauxite. Sintered bauxite is used for deeper and harder formation. It's an example of the proppants used in the frac jobs. That was general information for you to have a clear picture of how a frac job looks like. So now I'd like to mention that frac became a very important player in the Canadian oil patch, and here's some facts. Hydraulic fracturing in Canada was first used in Alberta in 1953 to extract hydrocarbons from the giant Pembina oil field, the biggest conventional oil field in Alberta, which would have produced very little oil without fracturing. So since then, over 200,000 oil and gas wells have been fractured in Western Canada. The productivity of wells in the Cardium, Duvernay, and Viking formations in Alberta, Bakken Formation in Saskatchewan, Montney and Horn River formations in British Columbia wouldn't be possible without hydraulic fracturing technology. And also, hydraulic fracturing has revitalized legacy oil fields. In our country, Alberta is the busiest province in terms of hydraulic fracturing. The shale gas fracturing in Canada has been concentrated in Alberta and northeastern BC, whereas fracturing in both Saskatchewan and Manitoba is for shale oil, also referred to as light oil. Recent studies are showing significant results. It is now estimated that 80% of the new oil and gas wells in Canada are fractured. Also, in my presentation, it is extremely important to mention the negative effects of this process. What can potentially go wrong? Many people are wondering, because there is a lot of information about oil and gas industry in mass media, and I'd like to say that in Canada in particular, currently there are no outright fracturing bans. Instead, there is a combination of strict rules and requirements in some parts of Canada due to either public outcry or lack of economic feasibility due to geology. But hydraulic fracturing in general has caused controversy and protests throughout North America due to the contamination of groundwater. For example, in 1987, the Environmental Protection Agency even reported its first documented case of groundwater contamination due to fracturing in West Virginia and USA. No Canadian jurisdiction has set up long-term monitoring wells to track the movement of contaminants from oil and gas drilling into groundwater. But there is also a well-known fact that fracking emits a lot of methane via fugitive emissions from the fracking itself, the venting and flaring of natural gas and pipeline leaks as it's shipped. Also, there is a very important thing that we need to keep in mind, that sometimes fracturing is associated with earthquakes. So the latest research by the University of Alberta indicates that fracturing can trigger small to moderate earthquakes. A 4.8 magnitude earthquake in January 2016 in the Fox Creek area of Alberta is the largest one in Canada up to date. The recent one that is possibly related to fracturing happened on November the 30th this year near Fort St. John in BC, and it was 4.4 magnitude. There are calls for more research to assess the risk of these earthquakes to pipelines, dams, and other infrastructure, as well as how they affect the flow of groundwater and migration of gases into the atmosphere. My presentation also has a slide with a picture of seismic measuring station. This particular one is in Alberta, but like I said, scientists are monitoring the connection of fracturing and earthquakes. So, in my summary, in my conclusions, I would like to say that in Canada, hydraulic fracturing as a well stimulation operation has become a very important part of the oil and gas industry's activity. 80%, like I said, of new oil and gas wells in Canada are fractured right now. Canada, we must admit that Canada has high work safety standards in the oil and gas industry, which along with the modern frac equipment definitely plays a very important and positive role during fracturing operations, because it's a long and complicated job involving high pressure pumping related risks. Like you can imagine, numerous pumping units and other imported equipment are working 24/7. And on the other side of the story, we would like to summarize that in fracking there are risks that in many cases it is hard to control, like impact on the environment, impact on people living near fracturing activities, possible long-term health effects, greenhouse gas emissions, and two major ones are groundwater contamination and change in seismic activity, including earthquakes. So, in my opinion, there should obviously be a balanced approach in this matter, because the multi-million-dollar excuse me, the multi-million-dollar fracking industry should consider all possible negative consequences and do its best to work out the game plan that will be safe for people and environment. Once again, my name is Alex Davidovich. It was my presentation about fracturing industry as a part of oil and gas industry. In Canada, its impact on the environment, on people, on businesses, and its positive effect on obviously the oil and gas industry processes. Thank you very much.